Hi everyone, welcome back. This time I'm going to be showing you how we can do a better job of calculating these coefficients here, A, B and C, of our quadratic model. Now the image there at the moment is the trend line that was inserted automatically, and the trouble with doing this method is that we are limited in the amount of precision we have for these values. It would be nice to get full precision on those values, and this is how we do it. So I will start by moving this information one column across, and I need this time to calculate the time squared, because in my quadratic model I don't only have a dependence on the x value, the years, but also on the x squared values. So I have to calculate what they are. I do this by using an equal sign, and then I highlight the cell A5 that contains my first year, and I use that inverted V shape. It's called a caret symbol, and that means to the power of 2. So that is the value there of 2017 squared, and I'll copy those down. Now I will go back to my data tab, the analysis menu, and we need our regression. This time I'll be highlighting the y values, this percentages, and when it comes to x values this time, I will highlight both time and time squared, because as you know, there's an extra part to our equation this time. It's no longer a linear model. Once again, tick residual plot and say OK. Now here is the information produced. To start with, we get two residual plots. The residual plots are pretty much saying the same thing. First one is just we say x variable 1, which is the times. The second one they've labelled x variable 2. That's the column I inserted with the time squareds. Now, I don't think that one's helpful, so we'll just throw that one away, and we'll keep this residual plot. I'll copy that one over and put that underneath my original graph. There we go. We can see the residuals this time. Well, last time, remember, the residuals went up and down by 0.1. This time, they're not as big. That's good. Also, last time the residuals had a clear pattern, a curved shape. These ones seem more random because we're sort of up, down, down. So the residuals here, I think, are telling us that our quadratic model is a better choice compared to the linear model. That's important. Now let's go back to our regression analysis. We can see the value of r squared up here, 0.99. We can see importantly down here, if I widen that a bit, we have coefficients. Remember, the coefficients in our model are the numbers a, b and c, and we have coefficients that belong to the intercept, the first and the second x variable. I'll be copying those numbers back onto my original sheet. Let's just put them in here for a moment. Now, as you can see, the intercept is the value of c. So we'll write c equals in that space there to give it a label. And you'd also see that the value of this matches the value we had from the automatic trend line. But the advantage, we get a lot more precision in the number when we use the regression function. X variable 1. Well, the first column, which was the times, the raw times, that's the x variable, and 93.54. There it is, 93.54. That's the value of b because it's the raw values of the x variable, the time. So we'll say this is b equals x variable 2. That's the second column I highlighted where the time was squared. In other words, it's the value of the coefficient a that belongs to the x squared part of our formula. So that's a equals, and it also matches what we have here. But again, the numbers from the regression function give us a great deal more precision than what we had available using the trend line feature. That's why they're preferred. These numbers will allow us to do much more accurate predictive calculations. Now, that's a fair bit for one session, so I'll stop here, and when we come back, we'll be seeing how to use these numbers to calculate our predicted time when the population fraction reaches 60%. Thanks for watching.